Thank you. Hi guys, good afternoon. Today I'm going to talk about the cognitive automations with machine learning and how they're going to impact on the cybersecurity domains. Like we have a different type of cybersecurity domains. So how it's going to impact on different domains. So first the agenda. Agenda is like what is cognitive automations and machine learning, introduction, learning curves, and one of the example. And another one is cybersecurity and its challenges. If I'm talking about the cybersecurity, we have different trends for the cybersecurity. Previously we have different trends, now we have different trends. And what are the new challenges we have and how we're going to mitigate those challenges. We're going to discuss about this here. So improvisation of cybersecurity resilience with the help of machine learning, how the machine learning going to be help in cybersecurity, and what the challenges we have in cybersecurity and how we're going to overcome with the help of machine learning. And the one is the cyber risk management. Basically it's talking about the evaluation of the risk identified, risk factor identified, and how we're going to mitigate them and how we're going to perform the risk assessment part. So a little bit about me, I'm a security professional, more than 11 years of experience, worked in different type of organizations, banks, I worked on different projects of information securities. So if you guys, any type of suggestion, anything, you just connect with me on LinkedIn. So the first section, we're talking about the cognitive automation and the machine learning. So like what the CA and ML, it consists of lot of the scenarios. If I'm talking about the adaptive learning, basically we have different type of threats, different type of attacks we are facing today's world, and they all are the new ones, sometimes 0 days we have. So we need an adaptive learning. So any machine, any environment that can learn from the previous experience to protect us and just change our IS controls on the base of previous experience. And we need to give a learning curve with the help of training data sets. We need to create a different data sets. In different data sets, I'm talking about we need to identify the features, patterns, different type of patterns we have, different type of features we have. So we need to find them and we need to create a pattern sets that we call as data sets. And speech recognition, we're going to analyze the audios, pitch levels, frequency of flows. So that's also consist of here. And natural process languaging we're going to consist of. So this is a high level flow of machine learning things. So first of all, what we do is we just analyze the data. We have different type of data. If I'm talking about useful data, unuseful data, approved data, restricted data, or critical data. So we need to understand all the data that our organization is dealing with. So we need to analyze all the data. After that analyzing of data, we need to categorize them, group them, or clustering them on the base of their nature. Their nature we can talk about, and on the base of rules, on the base of privileges, and on the base of restriction, we going to extract the data, and we basically grouping them in clustering them. And after that, we going to go for the third phase, which we call selection of the unique features. So we're going to select a unique feature. If I'm talking about the unique feature, if I'm talking about the SQL injections, it's a website attack. So if I'm talking about the SQL injection, we need to identify the SQL injection. So we need to identify their payloads and everything. So it will be a different type of clusters. So we need to create a data set, separate data sets for that type of features or the pattern. So after that, we're going to create a useful data set for the SQL injection, maybe unapproved data, unrestricted data. So after creating a data set, our training machine is ready. After training machine, we're going to pass the real data to it so it can learn from that data sets and it can update the data sets. So this is an example in a high level what insurance company dealing with, how they make the work optimize, how they perform, cost reduction part while decreasing the employee, how they increase the automation. So if I'm talking about in insurance, we have the inquiry. The inquiry comes in and we have a live voice chats that will dealing with those queries. We just basically call them chatbots. We have Facebook have, Twitter have, a lot of companies having chatbots. So on the base of that, it will decrease the employees in a company, that will reduce the cost. Another one, it will increase the processing speed, processing request speed, and like we are the humans, we perform the errors, but it's automation things, it's not going to create any errors. So after that, like when we need to extract data, we're going to perform a regular expression things. So that type of also dealing with this part. So after that, we dealing with the tagging and matching scenarios for legal requirements. If I'm talking about like how the business process running, they have consistency in them or not. So that should be in lining with the help of cognitive automations. So if I'm talking about the approvals, basically the company compliance things. Like if I'm working in Singapore, so my legal compliance are different, my regulatory compliance are different. But if I'm working in Europe, we have a different compliance over there. So how are we going to map them? So that will be done by the automated process there. So this is all about the automation thing in the insurance with an example. So next, we're talking about the cybersecurity and its challenges. Like we have different type of cybersecurities, and it will be changed. If I'm talking about the old, like we all are study about the cybersecurity. Previously, we just dealing with only the cryptography things. That's a mathematical things. We just perform the data transformation with the help of cryptography, in which we hide the data, we manipulate the data. These things we performing. And previous, if how we analyze, like this is a tradition, old tradition, and this is the new tradition. I analyze on the base of some type of attacks. I just calculate some of the attacks between 1980s to 1990s. These attacks are on banking's user passwords attack. So basically brute force attack, hashing breaking, encryption breaking things. So our previous all type of hacking attempts happen on the cybersecurity protection where the cryptography is there. And if I'm talking about after 2000, we have the attacks, DDoS attack we have, virus attack we have, bombs attack we have attacks on infrastructure. So it's not only we talking about the cryptography, we're talking about different anomalies, we're talking about different viruses, we're talking about denial of services. So after 2000, it's not only about the cryptography. And if I'm talking about like machine learning can add a value, work on the basis of the prediction analysis. Just like if any event already happened and if my firewall able to bypass it, so it will learn from that and it will add that rule, and next time it will not going to be happen. So machine learning can learn from itself, basically adaptive learning. So it will add the value in that type of scenarios because it's not only about the cryptography stuffs. And cognitive automation help in process optimizations, less errors because it's automated, and staff reduction, basically reduce the cost for a company and get away from the redundant works. So machine learning basically learn from different scenarios, supervised learning, unsupervised learning. So if I'm talking about cybersecurity in challenging and how machine learning help in that part. So we already see the scenarios like we all are using Outlook, we are using Hotmails, we are using Gmails. So you can easily see like if any mail you don't like it, you just click on the spam. So Google machine learning algorithm learn it, it's a spam. So next time that type of mail always be grouped in the spam folder. So it's basically learned from the adaptive things. We report it, they learn it, and they basically increase their skills, learning skills. So spam mitigations is very nowadays, like if I'm talking about the Outlook, they even divided the inbox into two parts, focused one and the others. So we can only see the focused email and we can see the other emails. So it will be learning from, it's basically a learning curve for different organization. And we have latest now like anti-phishing also over there. So it is also the new things that machine learning improvising it. Like if you see any email and you feel it is a phishing attempt, you just need to click on that part and it will be counted as a phishing email, and next time you will not able to see that type of mail. And it will help in the user identification, it will help in detecting identification theft, and it will help in information leakage detection and the prevention. Basically in DLP it will going to help a lot, like labeling of the data, data classification. Like if I'm not the privileged authority to see the data, I can just set a rule over there and it automatically just perform the things for me. So if I'm talking about next section where improvisation of cybersecurity resilience. So cybersecurity, machine learning help a lot in cybersecurity nowadays. We have a lot of tools from dark matters and other organizations. So if I'm talking about the security incidents, security incident like we have external incident, we have internal incidents. So we have different type of incidents. So if I'm talking about the external incidents and I'm categorizing into the different scenarios, one is a malware activity. Like external incident, we have spams, phishing attempts, or basically port scanning things and different type of scanning, website scanning stuffs. So we analyze, basically machine learning is all about analyzing the data. So we analyze our outer external incidents, if it is related to network part, untrusted HTTP, and if it's about the incident reporting, victims, non-victims. So first of all, we analyze the data. After that, we process the data and extract the features on the base of time. Like if I'm talking about the brute force here, so brute force required for every attempt, it will require nanosecond sometime, microsecond sometime. So we can analyze that type of behavior. We know like this is an attempt from like a script or from program. It's not a real human being. So we need to analyze that data and we need to categorize them and we need to create a features for that part. So after that, we need to put them in a data set to create a new data sets. So we create a data set after that, and after that we're going to analyze it. So this is about security incident. If I'm talking about the fraud detection, previously how we perform the fraud detection, like every person, like if my bank is in UK, so I need to take a permission from them to access their Visa card here. I need to inform them. So basically unusual activity happens or unapproved activity happen, unapproved transaction is happening. So these are the manual stuff happening. So it involves lot of involvement of humans. And when the humans involved in a lot of the things, there is a chances of errors. So it will increase lot of the human involvement in tradition fraud detection parts. It will decrease the speed a little bit, not that much, because it's not that much automated, so the speed is medium. And the accuracy is also medium because we perform the errors, humans. So after that, what the new trend is, when we have machine learning, we have algorithms for that purpose, for detection the anomalies, for detection the unapproved transaction. So those will be on the real-time basis. So human involvement is like nothing, it's very low. If I'm talking about speed, is very high because everything is automated over there. And if I'm talking about the accuracy, is about to be 98%. So machine learning help in fraud detection part. If I'm talking about the intrusion detection, like we have different type of intrusion detections for network, for host, for external intrusion, internal intrusions. So why we need analytics? Because we need to analyze, because cybersecurity was changing very fast. So it should be updated. It should be analytics on the daily basis, or maybe weekly, quarterly, it depends on industry to industry. So after that, how are we going to perform the intrusion detection with the heuristic analysis, anomaly detection mechanism. So what type of algorithm we are going to use. And if there is a machine learning for performing the intrusion detection part that will be used in NIDs nowadays, so it will add a positive timely feedback, real-time detection, it will decrease the risk impact, and it will add the value to the organizations. If I am talking about threat analytics, we have different threats, external threats, internal threats, website threats, network threats, asset threats, human threats. So we were going to follow the same scenarios. We need to analyze all the type of data, categorize them, create a pattern for us, create a data set. After creating the data sets, we're going to evaluate our real data with that data sets. And it's a adaptive learning, so it will learn automatically from the new type of attacks. So I'm talking about the another part, cyber risk management. So I explained this part with an example to you guys. I created a small scenario. So it basically consists of event-based analysis with the help of machine learning for different type of attacks in network flows. So here we have different type of assets in our organization, and these assets are connected with the endpoints in our organizations, servers, systems, data centers. So they have network flow. Every device have the network flow. So all the network flow come to the proxy server where they are collected. So they are collected at the proxy server, and those go to the SIM also here. This is a SIM for the forensic investigation. What this SIM is do, verify the incident, what type of incident occurred, maybe external or internal. Determine the severity level as per the company risk policy. And it will reconstruct the event for us, so it will be utilized by our performance monitoring. And review and determine the root cause for that particular incident. So all the data come to the proxy itself because everything is passed to the proxy in network. So after that, it's connected to the real-time SIM. Maybe you can use real-time SIM of, there is a lot of organizations who providing real-time SIM. So it is creating a automated real-time alert for us. Consists of event log management, enterprise security management stuffs. So it will help to correlate the threats, what type of threats we have and how they are correlated. So we need to use those correlated threats for creating our machine learning pattern. Anomaly detection, like what type of new we are facing in our organization, if anything new, how are we going to categorize them. So that's part also going to be performed here. And root cause analysis. Here also we have a root cause analysis, but this is also a different, it is a real-time root cause analysis. So what happened? These two are going to communicate with each other. So this is basically a performance monitoring network or the application, like is basically consists of how our network is. It is optimized. There is a no broadcast storm, collision storm there, everything's working fine. So this is basically give us real type of scenarios, our network is optimized. It's not dealing with anomalies. So it will perform the deep packet analysis. It will perform the forensic capabilities for us. Event impact assessment, it will going to perform. Network traffic analysis, basically net flow analysis, it will going to perform. Threat intelligence going to perform for us. Threat intelligence, threat analytic, it will going to perform for us. Payload analysis, like if it is an external attack, someone put different payloads, custom signature for IPS, everything going to be analyzed here. Application activities is going to analyze. And behavioral monitoring, it will going to perform. But like for both, for the communication between them, we need a communicator. Like we need to create a data set for our network event base. So we need a format for that. So we need to use here I didn't mention that device. We need to use here common frame connector. So like it's having a different type of report generation mechanism. This having a different form of report generation mechanism. This having a different form of report generation mechanisms. But we need a same type of report. We need a same type of format. So that we need to connect our communication connector. So after that, we're going to create our event data sets. Event data set consists of, like we already talked about the patterns here. We have a different type of patterns. So all those patterns will be grouped, clustered to create our event data sets. That event data sets will be used with the analytical engine to predict the new type of like what type of IS control, information security control we need to use, and what type of new measures we need to use to protect our network. And it will also help us in our risk assessment part. We already know our organization risk appetite. So how are we going to fulfill that appetite? What type of risky factors we have that impacting our network? How type of training we need for an organization to remove those or to mitigate that type of factors. That's it from my side, guys. If you have any question, you can ask me, or you can mail me, or if you need any help, you just mail me.
Thank you very much.
Thank you.
Are there any questions for the audience? Okay. Well, if there are no more questions, please be aware that you will be around for the entire day, so you can ask him any questions you want later. Give it up one more time.
Thank you.